we're in the home stretch, right? So I've got my delta 1, I've got my delta 2. This is the third screencast, by the way. Now I'm just doing some algebra. So I moved this f of t over g of x over here, and I was able to simplify this into L minus epsilon over 2 minus some big mess of stuff. Now it's going to be less than, well, here, once I clear that out, this is the only thing that's left. So I'm going to be left with f of x over g of x, which is good, which is less than L plus epsilon over 2. I move my f of t over g of x over here, and I get, what's this going to be? This is going to be a little ugly. Plus, I'm going to write it as plus, and then I can write it as f of t minus L plus epsilon over 2 g of t all over g of x. So this is my master inequality right now. So here's what I want. I want to prove that the limit of f over g equals L, which means I need, maybe I'll write over here, I need to get at some point f of x over g of x minus L is less than epsilon. Well, if you notice this, I'm actually really close. If I can make this thing less than epsilon over 2, and that thing less than epsilon over 2, whatever they are, I'd be good, because then I get L minus epsilon over 2 minus epsilon over 2, which would give me L minus epsilon. And here I'd have L plus epsilon over 2 plus epsilon over 2, which would give me L plus epsilon, which means that I would have exactly what I need, and so this would be the limit. Well, this is where the delta 3 comes in. So notice these are very similar things, they're just a little different. You have f minus L plus epsilon over 2. Here you have L minus epsilon over 2 minus f. But regardless of what they are, notice that the top two things, which I'll circle in red, this thing only involves L, epsilon, g of t, f of t, and t is a constant, remember. So the numerator here is constant. Similarly over here, I have f of t, I have L, I have epsilon, and I have g of t. These are all constant. Well, if I want to make these as small as I can, and notice that the denominator here is not constant. So here's my strategy. G of x is going off to infinity. So I'm just going to make g of x as big as I need to shrink this constant down to be less than epsilon over 2. So here's how it works out over here. So here is the bigger numerator will be right there. Right? By definition of a limit going off to infinity says that for any m, I'm going to set my m equal to the bigger numerator, whichever one of these is bigger. There exists a g of x such that, this bigger numerator times 2 over epsilon, by the way. There's going to be, you can make it small enough so that, make it as small as you want. So I'm going to make this thing less than 2 over epsilon times the bigger numerator, which is going to imply, if you do the algebra, that g of x, that this thing is going to be less than epsilon over 2. So how does this look? I guess my deltas are in blue. Right? If I go to here, I get a delta 3, and since g goes off to infinity, there is a delta 3 such that it's always bigger than or equal to 2 over epsilon times the numerator, and then whichever one's bigger. So with that, once I do that, I get L minus epsilon over 2 essentially, so that's L minus epsilon, f of x over g of x, L plus epsilon over 2, which is L plus epsilon. And so what I can finally say is, let delta equal the min of delta 1, delta 2, delta 3. Then what I get, x minus a less than delta implies this thing is true, which means that f of x over g of x minus L is less than epsilon, which means that this limit holds. And we're done with this mega proof. Enjoy.